Alright, here we have a squirrel in a nearby tree drops an acorn and just misses a dog. If the acorn has 255.5 joules of potential energy and a mass of 1 kilogram, how high up is the branch from which the acorn fell? So the first step, we're going to write our equation. GPE is equal to the mass times the gravitational constant times the height of the object. Now what we're going to do is we're going to identify our variables. Now we're going to go back and reread the question. A squirrel in a nearby tree drops an acorn that just misses a dog. If the acorn has 255.5 joules, so we add 255.5 joules of potential energy and a mass of 1 kilogram, how high up is the branch? So we need to figure out how high up. So the height gets the question mark. We know the gravitational constant is 9.8 meters per second squared. So now we need to solve for h. If our equation is this, GPE equals mgh, we need to solve for h. We can do that by dividing both sides of the equations by mg. Mg go away. So our new equation is height is equal to the GPE divided by mg. Move that to the side. Now we can solve our problem. H is equal to GPE divided by mg. Now we're going to plug our stuff in. GPE is 255.5 joules divided by the mass is 1 kilogram times the gravitational constant of 9.8 meters per second squared. Here you might get a little bit confused, so I'm going to take this joule and I'm going to expand it out and get a different color. We're going to take this joule and expand it out. If you remember over here where GPE equals mgh, we can see a joule is equal to a kilogram meters per second squared meter. So I'm just going to expand that here. So a joule is a kilogram meter per second squared meter. So what we're going to do next is we're going to solve for our denominator. So h, and while I do that, I'm going to substitute my units for a joule. So height is equal to 255.5 kilogram meters per second squared times a meter divided by 9.8 kilograms times meters per second squared. Now it's more clear that you can divide kilogram by kilogram, meters per second divided by meters per second. We're left with a meter, which is the unit of height, so you know that you set the equation up correctly.